So today we're going to look at another type of bonding, which is called covalent bonding. Before we do that, we're going to whiz back through really quickly one more recap of ionic bonding, which I'm sure you understand perfectly by now, but we'll go through it again one more time. So remember, with ionic bonding, electrons are either lost or gained, resulting in what we call ions. And in this example here, you can see K, which is potassium, and F, which is fluorine. Potassium has 1 electron in its outer shell, and fluorine has 7. So in this diagram, we're not showing the nucleus, we're not even showing the inner electrons, we're only interested in the outer shell. So potassium will give up the electron in its outer shell, and that electron will be picked up by the fluorine, which means both the potassium and the fluorine will now have a full outer shell. And that creates a potassium ion, which is a positively charged ion with a positive 1 charge because it gave away 1 negative electron. And the fluoride ion has a negative 1 charge because it picked up 1 negative electron. And when we talk about an ionic bond, all we're really talking about is the attraction force between positively charged and negatively charged ions. So because they have an opposite charge, they feel a force of attraction, a bit like magnetism, and they bond together, and we call them electrostatic forces. So that's just a fancy word for saying one's negative, one's positive, and they're attracted together. So let's have a look at covalent bonding, which is another type of bonding that atoms do. So just like in ionic bonding, atoms which bond covalently are still trying to achieve a full outer shell. Another way of saying that is to call it a noble gas configuration, because the noble gases are in group 8 and they all have full outer shells. So whenever you see anything that says noble gas configuration, it's just a way of saying they've got a full outer shell. So in covalent bonding, rather than losing or gaining electrons, atoms achieve a full outer shell by sharing a pair of electrons. And the shared pair of electrons is called the bonding pair. So let's take a look at an example. So chlorine atoms tend to bond with other chlorine atoms to form the molecule Cl2. And chlorine, remember, has 7 electrons in its outer shell, so each chlorine is looking for 1 extra electron. Now, of course, it can achieve this by finding a metal that will give away electrons, but if a metal isn't available and there are many chlorine atoms together, they will share electrons to give themselves full outer shells. So as our chlorine atoms move together, they can link themselves together, and each chlorine atom can share 1 electron with the neighbouring chlorine atom, and that gives both of them a full outer shell, or what we call an octet. Just 8 electrons in the outer shell. So you can see here, by sharing 1 electron each, our chlorine on the right has got 8 electrons, and our chlorine on the left has got 8 electrons. But there are 2 electrons in the middle there, the pair in the middle, they are being shared by both of those chlorines, and that is the sharing pair or the bonding pair. Now, because our chlorines have bonded together by sharing only 1 electron each, there is a single bonding pair, which is called a single bond. And when you draw chlorine, you don't actually need to draw all of those electrons. You can show chlorine bonded together covalently by drawing 2 chlorines and then adding a single dash between the 2 atoms to show a single bonded pair. So what we're showing there is the chlorine molecule Cl2. Okay, let's have a look at another example. So oxygen tends to be found as what we call a diatomic molecule, which just means 2 bonded together. So O2 is how we find oxygen in the real world. And oxygen has the atomic number 8, so it has 8 protons, which means it will also have 8 electrons, which means with the 2 on the inner shell, each oxygen atom has got 6 outer electrons. So here we've got 2 oxygen atoms showing our 6 outer electrons. But because each of them has only 6 in their outer shell, they both have 2 unpaired electrons. So sharing a single pair, like we did with the chlorine, won't work for oxygen. So what oxygen will do is it will pair itself off with another oxygen atom, but each of them will share 2 electrons. And if we look at our oxygen on the right-hand side, you can see that if you include the 2 pairs of shared electrons, the oxygen on the right hand side has 8 in its outer shell, and the oxygen on the left hand side also has 8 because the 4 in the middle are all being shared. So that is 2 pairs being shared. And that means that O2 as a molecule has a double bond. And just like we showed Cl2 with a dash in between to show a single bond, you can show that double bond by writing the 2 O's for oxygen and putting 2 dash lines to show that it's a double bond. So that is the molecule O2. So the important point here is that whereas ionic bonding was all about one atom giving away electrons and another atom picking up those electrons, covalent bonding is all about sharing. The electrons don't leave the atom at any point, they're just linked together and are shared between 2 neighbouring atoms. And the other thing to remember is that covalent bonds only happen between 2 non-metals. So if you have a metal and a non-metal, you will get ionic bonding. And if you have 2 non-metals, you will always get covalent bonding. So now I'm going to get you to pause the video and answer the first 5 questions that are below the video. So pause and do that, and once you've completed those questions, come back to the video and press play and we'll carry on. So for the rest of your time in this lesson, I'd like you to work on the 2 worksheets that you can see on the screen now. They're also attached to the task on Go for School, so you can download those as a Word document if you want to. Now, ideally, you would need to print those out so you can handwrite your answers on the sheet. But if you can't print them out, no problem at all. Just recreate the table in your book or on a piece of paper and fill in those blank spaces. The important thing is, whether or not you can print it out, that you have a go filling in the blank information on those tables. So you can see at the top of each table there are 5 headings, and those are the 5 different ways of representing a molecule. So the first heading is a bubble model, which is simply drawing those molecules as circles and labelling each circle with the chemical element that it's representing. The full outer shell dot and cross model requires you to draw the actual electron shell or energy level and show the electrons that belong to each atom. And you can see on those examples that some of them are drawn as dots and some are drawn as crosses. So if you look at the top example, the one with the dots belong to the oxygen and the one with the crosses belong to the hydrogen. They're just shown as dots and crosses to make it easier for you to see which electron originated on which atom. Then we have the simplified dot and cross diagram, which is the same as the previous one, but you don't have to bother drawing the electron shells. You're just showing the electrons themselves. And then very importantly, we have what's called the structural formula, and that is where you just draw letters to represent each atom, and then you put single, double or triple bonds between each of those atoms to show whether it is a single, double or triple bond. And then the last column is just the chemical formula. Now you should be able to work out the chemical formula for any of those molecules that you don't know by working out how many electrons they'll need to share and thereby working out how they bond together. So there are 2 worksheets for you to try. The first one, number 1, is covalent bonding in compounds. Compounds, remember, are made up of 2 or more different elements. And then the second sheet is covalent bonding in elements. And all of these are made up of only one type of atom, but they covalently bond together to form a molecule. So have a go at all of those. You can email me in either a Word document or a picture of your work in your book or on a piece of paper. And as always, if you're stuck or you need some help, please either drop me an email or you can always join our support session, which is at 3:30, and we can go through any of these that you're having trouble with. Okay, good luck, and I'll speak to you soon.